So there is hope for all of us, isn't there?
Thank God, huh? Which is another thing that's kind of determined towards the end of the chapters that we got into. That, yeah, seeing as I'm getting older, going back to God is something that's normal in the genes. And I go, yeah, they got me right down to the God level.
Not a bad thing. Not a bad thing. So, it's kind of interesting because Angela came into the course with already a 4-year degree in psych, right?
Right.
And we did a lot of psych work because we did a lot of personality development. We did risk-taking genes. There are some very clear genes that contribute to personality, and also addiction, things like that. So, couldn't you kind of tie the two together in a little bit of our genetics and your psych background?
Well, and that was what I was first discussing, like with the psych background, being an older student. Those were classes some time ago. I kind of had this stereotypical view on the psychology part. So this class really opened my eyes to the genetics part, and that addiction, you might have that gene for addiction, or you might have the gene for the thrill seeking, the long D4DR gene. That doesn't necessarily mean that you're going to express it, because there's always the component of free will, and we as individuals can make choices in our lives. And so it might be there, but it just may not turn on.
Yeah. And the other complex thing about specifically addiction is that we have these genes that predispose us to being addicted, but there's no gene in the human genome that says you're going to get addicted to cocaine. There are genes within our genome that say you can have a high tolerance to possibly alcohol, or alcohol stays in your system for longer, which predisposes you to being an alcoholic, but it doesn't determine that you will be an alcoholic.
I think it's interesting then, this discussion, we reinforced Angela's first statement right off the bat that it's not a nature versus nurture, it's a nature via nurture. Yeah. And here we are, we started discussing genetics and kind of the scientific side, and we've blended so easily and so intricately into the mind, the psychology behind our physiology, and not just the determinant that our genes supposedly set for us. You can carry the gene with the predisposition for alcoholism or drug addiction, but as was already said, free will does exist in the world, and it kind of plays into the nurture, like your environment. If you're brought up in a home where, say, you have 2 sons and an alcoholic father, there could be one son who says, my father was an alcoholic and I followed in his footsteps because this is what I saw and this is what I know. And you can have another son that says, I watched my father and I made this decision that I'm not going to be this way. Mm-hmm. So it's really just interesting to see how we can so beautifully combine all these different subjects and all these ideals and theories, and we can kind of start to understand ourselves a little better that way.
Yeah. And to even further blur the line of nature and nurture, we actually have genes within our genome that only turn on if certain environmental factors are present. Like one example of this is there's this specific mouse that has one gene that determines how anxious the mouse is going to be. And it can either make that mouse very anxious or not anxious at all. And it all depends on how often the mother rat licks their child rat. So if the mother licks their child rat more, this gene turns on. And if the gene turns on, they become less anxious. And this is because, like, the gene protects the rat. If it's in a high stress environment with not much nutrition, it needs to be more anxious so that it is able to avoid predators more. It's able to take food when it needs it. But if the rat is in an environment where there is readily available nutrition, there's not many predators, if it's anxious all the time, it's actually going to develop health problems. So the genome basically responds to the environment and determines the response that it exhibits in its phenotype, which is the physical manifestation of an organism's genome, to what's happening in the environment. So there's really this like interplay between our nurture and our nature.
All right, Sam, you just did an excellent job of summarizing a classic experiment in biology. And that classic experiment is one of the best that we have to date to understand epigenetics. So when you guys say nature via nurture, you're really talking about the fact that we now understand genetics enough to know that there's epigenetics going on all the time. And that epigenetics is you're born with your genes, but they're not determinate.
Yeah.
That your environment is going to influence how those genes are expressed, how those genes are turned on and off, as you so eloquently explained. And in fact, if you really want to understand this classic experiment in epigenetics, you should go to the Learn Genetics site at the University of Utah. So anybody can Google this. Just Google Learn Genetics at Utah. .edu, and you can do your own little experiment with the rats.
That's right.
Because it was interactive, wasn't it? You got to actually determine how much they got licked.
Yeah.
How much is mama licking the rats? But, think about that. Think about what that does for us as human beings. Is that telling us that our maternal care in those early periods, those critical periods of time, is essential to personality development, our ability to handle and cope with stress, other factors? Does that make sense to you guys? That would have been an important piece of the puzzle of who you are?
Absolutely.
Wasn't part of the study, though, they ended up switching the rat babies? Well, in the real world, we can't switch babies to do that. Yeah. So we have to rely on twin studies and things like that to actually determine that in the human environment.
Yeah. Part of the nature of science is that a lot of the studies that we do on animals would be so unethical to do on humans,
Exactly.
So we have to rely on inference. Like, we can't know for certain that humans have similar epigenetics, but we can make the inference that if this is happening in animals, if we were to do a similar study on humans, it would probably exhibit the same results.
I find this so absolutely fascinating because I was adopted and I was in an orphanage for my first 9 months. Wow. So to me, this is very interesting, and it's hitting home a little too closely.
You should take Dr. Urbano's class.
Yes, I should, shouldn't I?
And a lot of the studies that we read about in the class to basically drive home these points were studies that were done with adopted children, twins who were separated at birth, because twins have the same exact genetic. Twins. Yeah, identical twins at least have the same exact genetic code. Fraternal twins are a little bit different. So looking at how they basically provide this like very interesting genetic research opportunity because it's the same genetic person, but if they're separated at birth, they were both in different environments. So seeing how much genes influence their traits, it's very easy to do with twins.
So twin studies are an essential part of understanding genetics.
You might.
Do you think you might have a twin? Do you know anything about your biological parents?
Just nationality.
Okay, so you've never tried to go back and open up the records to...
Closed. They were closed.
Okay.
Sealed.
I think after so many years, you can actually go back and have those reopened. But, it's all an individual decision that you'd have to make if you were interested in that. Okay, so who thought of something else as we were talking along the way? Yes, no, maybe?
The class itself, it wasn't just about genetics, though. I think we're kind of like getting just on genetics, and we talked about a vast majority of information from things from Kinsey. We had to watch the Kinsey movie and write papers on that, and cancer, twin studies, personalities, epigenetics, eugenetics. There was just a vast amount of information that we covered in the 15-week course, and it was very, very good to learn a lot of information that, as my classmate said, we wouldn't have been exposed to in a general biology class.
Yeah, and one of the where this class really like broke the boundary of genetics was we assume that you know, this person is going to age quicker because they have this certain genome, and learning which genes cause certain behaviors and why specifically why a gene causes someone to age is really because the gene encodes specific kinds of proteins and enzymes, and it encodes them in a specific way. So that's what really interested me because, for instance, like with aging, I looked into what those enzymes did and how you can basically supplement those enzymes into your system if you have a genome that doesn't necessarily supplement them to your body naturally the proper way.
Okay, so now you're actually beginning to touch on one of the key epigenetic factors in our lifetime. Sorry.
No,
and that's nutrition. Mm-hmm. It's what we do to our bodies, what do we put into our bodies that's going to influence our genes. Mm-hmm. And that has to do with both nutrition and lifestyle choices, right? So how we eat and how we treat our bodies, whether we exercise them or sit on the couch as a couch potato, or, you know, whether we smoke or whether we don't expose ourselves to nasty chemicals and additives and maybe too many carbohydrates, 500 times a day, dosing with Coke and whatever other soft drink might be our flavor of choice. But all of those factors play a big role in how those genes are expressed. So we're back to nature via nurture.
Mm-hmm. Yeah, because our brains actually, genetics determine how well our brains are at cleaning up neurotransmitters. So if you have a genome and you're unaware of this, and if you have a genome that is not so great at clearing up those neurotransmitters such as dopamine, serotonin, they can sit in your brain and cause issues. And if you don't know that, you'll continually go back to abusing substances to supplement them. So it's important to know about your genetic code.
How about you, Juliana? The aging chapter? I thought you were sort of intrigued by that chapter.
I thought it was very interesting when we got into the Alzheimer's and how they have a snarl of knots that get in there before the plaque starts building, and how we can, do everything that we can to stop it. But right now there is no cure for this. And the only treatment is like Tylenol to stop inflammation or something like that. That kind of hit home. I mean, there's a lot of people I know that are my contemporary who have Alzheimer's or are going into dementia. And these are things that, will affect a lot of us in my time. So I was very surprised at the numbers for that.
Mm-hmm. Mm-hmm. Yeah, it's interesting because, as I think Sam said early on, the textbooks, which aren't really textbooks, but the readings that we did in this class were just jumping off points. Mm. And then those jumping off points kind of led us to further research. And that's a very important way, I believe, to study genetics, because the amount of information that we know and the scientific advances that are made in the field of genetics, along with several other scientific fields, but especially in genetics, kind of doubles like every 2 years. So anytime a textbook comes out, it's already 2 years old before it hits the shelf, which means already it's sort of outdated by the time, you're selecting it for your class, which is why I chose to not select one of those kind of textbooks, but to give you guys some interesting reads that would kind of foster deeper critical thinking and further research.
Yeah, and the funny thing about genetics is it's only 3 generations old. So certain studies that we want to do about aging, we've only had, since genetics has even been a science, 3 generations of people to do those studies.
Yeah.
So it's still an incredibly new field. And it's amazing how much we're learning about basically everybody's blueprint.
Mm-hmm. Okay, so 3 generations if you're talking about molecular genetics from the time of Watson and Crick, who in the 50s discovered the structure of DNA. Yeah. Mendel goes back a few more than 3 generations, but
for sure.
Yeah, for molecular genetics, it's 3 generations. Right on, Sam.
Yeah.
Another thing that I found interesting in this class that we discussed was the 23andMe.